ID is ABS269 and title is Objectives Classification Approach for Impervious and Non-Impervious Surface in Satellite Images. I'm presenting this paper, Dr. Pankaj Pratap Singh, and my co-authors are Sujma Basumatari from same institute and the other co-author Professor Ardigal from IIT Roorkee. So these are the contents of the presentation. OBIA, then the object-based classification, how it's worked, then the segmentation approach, multi-resolution, utilize KNN algorithm, then discuss results, analysis, and then conclusion and future scope. So object-based image analysis, it's a very important and very useful approach in LULC classification. And there is a, already we know there is a in a pixel based limitation of the pixel resolution also. Because of that we have to require the object based approach, because this whatever is there, object is there, it can be identified as a object in a image. But there are some challenges are there, and as obviously we can see unsupervised classification, supervised, and this era is coming for object based image analysis, and based on this we can do this analysis. So here in the object based we can do the classification. First we have to require the segmentation. So whatever the homogeneous object is there, by using this approach multi-resolution, then we have some features will apply, and based on that we will try to merge them, and then those sample will be assigned as a classes. So this approach we can just shift the focus from individual pixel to the spatial scale of object as a group of pixels which are having some similar properties. So this is our the framework, that input image, as mentioned, segmentation approach. We will have the hierarchy will be there, based on then in this hierarchy then sampling based on the features, then the classification, this approach will apply, and we will have the classified image, and last we will do the assessment part. So multi-resolution segmentation, this is the first thing that is to be applied. So here the scale parameter, as long as scale parameter is not locally extended, multi-resolution segmentation merge smaller items into the larger units. So this is the scalar parameter, is very important. Then we will have these are the some other color heterogeneity, shape heterogeneity, compactness. These are the very important part, as the descriptor part will play a role in the segmentation. Then there is a, like already we have mentioned, color heterogeneity. So how this particular is calculated, based on this we will have this weight factor, we will have standard deviation, and we are using the number of bands. So in each band we will have to calculate here the deviation, how much deviation is there in the each and every bands. So this will define the heterogeneity, and this will play a major role in the segmentation. So this is the segmentation before, and we have already mentioned the scale parameter is very important. So 30, here it's 80, so we can see how much this result is changed. If we have a small scale, we will have a very small level, we can see the segmentation segment is there, but here we have a bigger segment because we have taken scale parameter 80. So now after the segmentation, the this part we have done, then we have to go for a KNN base, that is the used for the algorithm for the classification. It's a non-parametric methods. So it is based on that object closeness. So here we will have the distance will be calculated by this formula. In this case, image object and sample object. So we will check a sample object is close to which image object. Based on that we will assign. So this is the way this algorithm will work. And now we are during that time we have to calculate several feature descriptor. We have already mentioned some of them: mean, brightness, geometry, compactness. Also already we have mentioned border index, density, rectangular fit, roundness, shape index. So these all particular feature descriptor is very important. Here we can say this is the like as a ambiguous case, considering this the homogeneity and the compactness. So like here we can see these are the 1 2 3 classes object, we can see 3 color. Here we have a little variation is there, but they are belong to the same class. So this is the kind of the, like we can see the how the homogeneity and the compactness are working. So the data set is taken here from the Wikimapia 1 meter resolution, and mostly we have taken developed suburban area images, because in this case we will have the some variation will be in the classes like road, vegetation, land, water, parking lot, and buildings also. So this is our the we have taken these images, 4 images from developed suburban, and these are the middle column we have segmented, and the last column is for the classified image. So the 5 classes here we have mentioned. So initially we have taken for 5, later we have taken the, because parking lot and building there will be very closeness. So these are the here quantitative evaluation. So we can say this is coming in these 2 images we are getting for the vegetation, very high values here, and vegetation we are getting, and in this particular also the kappa values also is showing that it's a good assignment here for this particular image. Now we have consider the another class also, that is the parking lot. So road, vegetation. Now the water we have not taken, because in these images very small part is there. Most of the it's here only the major challenge is here parking lot and building. So we have considering this particular. So here we can see this the big areas here, like this parking lot here. We can see in the case of the first one we are getting this particular kind of the, in the vegetation we are getting good, but we can see in the parking lot and the building is very challenging. And we can see in the fourth, this second, this particular image, we can see this building is giving better kind of the assignment here in this particular scenario. So we can see here the feature descriptor we have used, and based on that we are getting this good kind of the assignment here. So these are the calculated final overall accuracy and this kappa values for all the images here. So kappa we already know that it will so the assignment agreement is there, that is it's showing better one for the first image, that is the first one we have mentioned, and this one actually. So based on these result study, we have highlight the segmentation classification as very crucial step, OBIC, for doing this classification. And for appropriate segmentation is also very important, which particular factor we have to take in. And the environment is used recognition, so multi-resolution segmentation also demonstrated that how the other segmentation and in the multi-resolution how it is better. And then we have in the there is another section in this developer, there is a KNN classifier, so we are getting 95 accuracy here. Obviously in some of the classes particular the accuracy is not very high level, so as in the future we have to utilize some more features also in this case, and then we have to also reduce the misclassification, so some deep learning, maybe other approaches can also be utilized. Thank you so much for giving me time and permission for this oral presentation through this video mode. Thank you so much.